let us come back and do the 2008 paper. Yes, let us read the question. So what is given to us? A first order reaction, first order decomposition reaction takes at 40 minutes for 30% decomposition. Okay, so that means a particular reaction for 30% to decompose, it took 40 minutes it seems, right? I have to find out the T half value, the T half-life period of that particular reaction. Simple. Let us write the data given to us. First, T is equal to 40 minutes. Fine. Now, they've given us first order decomposition. So, write the formula. K is equal to 2.303 by T log A by A minus X. Correct? Right. Now, in this particular thing, T I already have. Now, A, how much is A initial concentration? A is equal to your 100%. Right. Now, your leftover percentage is 100 minus 30, A minus X. This becomes 70%. Now substitute the values. Simple. Get K is equal to 2.303 by your 40 minutes and your log 100 by 70. Done. Right. So you just try to solve this. When you solve this, you get an answer of 8.918 into 10 raised to the power minus 3 minute inverse. Done. With this answer, I'm still not done with the numerical. They asked me to calculate T half. We very well know. Let us name this as A, and let us take the very well know half-life period in the first order rate equation, which is equal to 0.693 by K. We've already derived this. Please watch the video for that. Now substitute this value of K here. What do we get? 0.693 by 8.918 into 10 raised to the power minus 3 minute inverse. That is the unit for your first order rate constant. When you solve this, you get an answer of 77.7 minutes. This is your half-life period. What did I do? I have written the given data. I have written the formula for this. After that, I substituted the values, and after substituting the values, I've got an answer of rate constant. That is in minute inverse. That is time inverse. With that time inverse, I've gone back to calculate the T half, because this is the relation for T half. Substituted the value. Finally, you've got an answer of 77.7 minutes.
The biggest online platform, learning platform in India. Let's crack it. I'm Vani Potepalli, the verified educator for grade 12 students, CBSE, ICSE as well as state board students are with me. Unacademy introduces Ask Unlimited Doubts for free students. Remember, will you give up or will you ace it? That is what is the difference. Giving up should never happen. You need to fight for it. For that, what should you do? You need to just ask us 7 doubts. Right, students, let's see how the feature works. Unacademy introduces one more important offer for you all students. That's nothing but ask 10 doubts now, and you'll be getting free Unacademy subscription. This date is particularly valid only till March 31st. You will be getting free Unacademy subscription for 15 days, students. Remember the date, March 31st is the last date. Use my referral code VANILIVE to unlock. Link is given in the description. Please go to the link, students. Here, asking 7 doubts for free is the main feature, where you will be getting free Creative Corner subscription. What is that? What do you have in that? You can learn robotics in that, magical skills in that, Vedic maths in that, musical skills, public speaking skills, and 100+ skills are there in Creative Corner, students. So what are you waiting for? It's only asking 7 doubts, and with those 7 doubts, you'll be getting all those skills to learn. Build up your communication, build up your lot of skills are there. Please join us. Only thing, you need to ask us 7 doubts. Link is given in the description. Don't forget to use my referral code VANILIVE to get 10% discount. It's up to you, students. You can opt for if you wish to join for 9th, 10th, 11th, 12th, you can utilize 1 month subscription, 3, 6, 12, 15, 18, like that. You have different combinations where you can join me and learn live sessions from me, students. These are the Unacademy iconic subscription features. Don't forget to use my referral code VANILIVE to get that 10% discount. Rates are given here. Go through it and join me live every day. These are the Unacademy subscription features where your 360-degree support system would be there. And if you're planning to join me, don't forget to use my referral code Vani Live Students. You can download the app from the Google Play Store. And as you all know, as I've been mentioning, please use the referral code Vani Live to get 10% discount. Download the app from Google Play Store, students. Remember to use my referral code Vani Live. Conducting free sessions for grade 12 students. So all the topics, dates, day, everything is mentioned. All are free sessions for you all students. So join me live every day, whether it is in the special classes or on the YouTube sessions. Join me using my referral code. I'll be waiting for you all students. Don't forget to ask us 7 doubts. If you're asking us 7 doubts, you will be getting the Creative Corner subscription free, where you can develop 100 plus skills, students. So link is given in the description. Please go through the link, enroll today. Thank you so much.
Back and solve the 2009 paper. So let us read the question first. So first order reaction has a rate constant of so much. Okay, let us write the given data. What is given to us? Rate constant is given to us. K, right? It represented by K. So this is your minute inverse. This is a unit for first order rate. Next, after that, if we begin with, so they've given us the initial concentration of R, the reactant, the initial, because why did I write this? They've written it as we begin with. So the initial concentration of R given as 0.10 molar. What concentration of the reactant will remain? So the leftover, that is A minus 6, nothing but R, here R naught, this is R naught initial. So they want you to find out the R value, that is A minus 6 value in the solution. What is the time interval given to us? After 3 hours. This is what is given. What should I find out? I have to find out R. Let us write the formula for this particular thing. So for the first order rate equation, the formula given is K is equal to 2.303 by T log of R naught concentration by R. Yes. Now, this particular thing, this is in minutes, this is in hours. So try to multiply with 60. So you get this also in minutes, 180 minutes. Done. This is over. Now start applying in this formula. When you apply this, what do you get? You get K is equal to 2. K value is already given. I have to find out your R value, isn't it? So K, how much is K given? 0.05 minute inverse is equal to 2.303 by time given is 180 minutes into log R naught. How much is R naught given? 0.1 molar, okay, divided by R. I have to find this R. Yes. So to find this R, I have written this formula. Let us see how can I simplify this and write. Now, what do? You take this whole of log 0.1 by R on this side. Log 0.1 by concentration of R. So what will happen then? You want to cross multiply with this. This becomes 0.05 into 180 divided by your 2.303 value. Done? Yes. Once you solve this particular value, you get an answer of 0.0398. So log of 0.1 by R is so much. Now what is 0.1 by R? This becomes anti-log of 0.03980. When you solve this, you get an answer of 2.503. I still didn't get the R value. So R is equal to I get an answer of 0.0399 molar because the concentration of this is measured in molar. So this is your sum. Yes, let us come back and do this question of 2009. Yes, basically almost all the chemistry, chemical kinetics numericals are based on this tabulated column only. So let us read the question, do it carefully. Almost all the numericals related. I have done a question on this also. Basically assuming the coefficients is alpha and beta in one of the numericals of your chemical kinetics. Please go to the playlist where I have done one more numerical of the same sort, but let us do this numeric. Now this is an experiment where there's a combination of two reactants, right? Now this is 2 moles and this is 1 mole, and they formed a product, NOCl, right? All this is a gaseous reactant, that is also gaseous. What do they do again? Let us see. They have given us or listed out 4 experimental data. Almost the same question, but maybe a small difference between that and this. They're given four experimental data with the initial concentration of NO and the initial concentrations of this one, Cl. And after that, they've also given me a data where initial rate of disappearance. What is the concentration when this particular reactant has disappeared? What do they want me to calculate? They want me to calculate the rate law. Okay, almost the same. After that, rate constant, done. I have to calculate the initial rate of disappearance of Cl in the experiment. Okay, so many things to prove. First, let us go step by step. The first thing here, and one more thing, is in this particular question, the time they've given it as 1 minute. Okay, that is right. First, divide into 4 columns. First important thing, I have to expression for rate law. Done. Most of the questions will start with this question only, a rate law expression, then rate constant, and if required, half-life also. Now, I am going to write the first law. First rate law, when we're writing, we very well know rate is equal to K into concentration of the reactant into concentration of the next reactant. Now, NO and Cl2. Remember one important thing. They've asked you to write the rate law, but don't try to write the coefficients immediately, because we are supposed to prove using this data the coefficients. Coefficient of NO and coefficient of this, I have to prove it, and finally you'll come back to this only, but I have to prove that. But when you're writing general rate law, take the coefficient of NO as P and Q. Any coefficient will do. This is done. I'll be getting, this is your first 1 mark. And I have to solve the next. I have to calculate rate constant. So let us start. First, start your rate. Compare 1 and 2. Then compare 1 and 3. Okay. 1 and 2. And then 1 and 3. Let us start. I'm starting with the first experiment. Rate. Okay. Let me write this as R1 for this. R1 is equal to K into NO. How much is NO now? Here it is 0.15 P. What is Cl? 0.15 Q. Correct? Yes. R2. How much is KNO? 0.15 P. How much is Cl2? 0.30 Q. Simple, right? Now, what is this whole equal to? Your rate also is there, isn't it? How much is this value of R1 here? It is your 0.6 for this, and this is your 0.4. Yeah, that no, not 0.4. It is how much is given to us. K to 1.20 is given to you. Yes, so let us write that 1.20. Okay, this is R1, this is R2. Now R2 by R1 is equal to K 0.15 P 0.30 Q divided by K 0.15 P and 0.15 Q. Done. Now this value again, yes, I've tried this value also, 1.20 by 0.6. Correct. What do I get now when I solve this? This and this gets cancelled out. So I can write this as, this is your whole quantity. So I can write as 2 raised to the power of Q, isn't it? 15 2s there, right? So 2 to the power of Q. Now what do I get here? I get twice, right? 2 raised to the power of 1. So what is Q? All bases are same. So Q is equal to 1. I got one answer, right? Let me come back and solve the P part. What am I going to take? I'm going to take rate equation 1 and rate equation 3. R1 is equal to K into 0.15 and 0.15. How much is this now? How much is the rate given to us here? Okay, I'll write rate on this side. This is 0.60. Okay, yes. Now, after this, let me pick up, this is basically R1. I'm picking up R3 now. So R3, K 0.3 and 0.15. How much is the rate given here? It is 2.40. Now divide R3 by R1. What do I get if I divide R3 by R1? I get K 0.30 divided by 0.15 is equal to 2.4 by your R1 K 0.15 and 0.15. Please try to mention the coefficients. This is P coefficient, this is your Q coefficient divided by 0.6. Now this and this gets cancelled, Q1. So here again what do we get? 2, and this is twice, isn't it? Now 2 raised to the power of P is equal to, when I cancel this, what answer do I get? I get 4 times. So I can write this as 2P as 2 square. Bases are common. So what is P value? P value is 2. I got P value as 2, Q value as 2, 1. Done. Now substitute. Now I'm coming close because I have to calculate rate constant. Start with the third step. So K is equal to, okay, rate is equal to K into NO. How much is the coefficient now? This is okay. This is P and this is your CL, Q, isn't it? Now write that P value here and Q value here. K, NO, P I've got it as 2, CL I've got it as 1. Now I have to find out K. So come out, take it out and write R, NO square by CL 1. Now what is the rate or the time given? What is this one? See, 1 minute, that is your 60 seconds. 60 divided by, how much is NO concentration? NO concentration is 0.15 whole square by CL concentration is 0.151. When I solve this, I get an answer of 177.77, right? So now this is your mole per liter. Write the unit, combine both, you get a new answer of mole inverse 2, liter inverse 2, minute. Okay, they've given this because already minute, then I've written minute. Done. Now I've got the rate constant. Now I have to show the disappearance of CL. Now how should I do that last one? Observe carefully. When you're doing the disappearance of CL, now simple, R is equal to K into your NO. Already I know the coefficient. Here also I know the coefficient. Rate constant value you've got, R is equal to 177.77 into, what is your NO value here at this particular point, because experiment 4 they said write that 0.25 whole square into 0.25. Once you solve this, you get an answer of 2.78 molar per minute. Units, so I've used this unit. Mole per liter, that is your molar I have written, and your minute. Because they've asked me rate of disappearance, isn't it? So per minute I have written. This is your whole sum. Please go through it carefully and note it. Basically your tabulated column numericals, very important to solve in steps. Let us come back and do the 2010 paper. Let us read the question. Explain the following terms, that is rate of the reaction and activation energy. Okay, I've done both the videos on this. Just go to the playlist in the chemical kinetics chapter. I think this particular rate of reaction, you can watch it in a video which is numbered as 2. And I think, yeah, activation energy, we have numbered it as 29. So video number 29. So please watch those. I've clearly explained the definition. I've also given you the information regarding how to write for an activation energy. I've also given you the formula for activation energy. Please go through that video. So for rate of reaction 2 and activation energy is 29. Let us read this question. Decomposition of phosphine, okay, phosphine pH 3 proceeds to according to this equation. There is one equation given to us basically, and they've given us, now because this is the first order rate equation, they said the rate depends upon only one concentration terms, that is, this is what they've given us. They also mentioned, they've also given us the T half of that half-life period of this particular reaction. What should I find out? I have to find out how much time is required for 3/4 of phosphine to decompose. Okay, so they've given this particular data. What should I find out? I have to find out the time, correct? How much for 3/4 of the decomposition. Now, as soon as such question is given to you, see whether it is first order reaction, second order, or zero order. So as we know, rate depends upon only one concentration term, so it is first order reaction. So write the formula. So given data in that. So I just mention, note this, A is equal to 1, basically A minus X is given to us because how much time to decompose the leftover, right? So 1 minus 3/4, this is 1/4 part is given to me. What else is given? T half is given to me, 37.93, right? Yeah, what should I find out? I have to find out T. Now write the formula. K is equal to S 2.303 by your T log A by A minus X. Yes, this is what we have learned already. Now substitute in the formula. So what do we have? What should I find out? I have to find out T, isn't it? Take this T out. What do I get? I get T is equal to 2.303 by K log of, what is A? So 1, isn't it? So 1 divided by 1/4A, isn't it? Yes, done. Now what is K value? Is K value given in this form, numerical? Not given, isn't it? So but I very well know, we very well know K is equal to 0.693 by T half. Yes or no? We know this formula for the half-life period. So substitute that formula here, 0.693 by T half. What is T half given to me? 37.93. So I can write the same as T is equal to 2.303 by 0.693 divided by 37.93 log. Now when I solve this, this becomes this and this gets cancelled. So this becomes log 4. Correct. So you can just solve this whole thing. Log 6 has 0.60 something, some value. Substitute the whole thing. You'll finally get an answer of 75.823 seconds. This is the answer. So your T half we have already got, right? So this is your answer. Please solve it. Let us come back and see the data given to me. Write the formula, which is, because I've written this, because they've already told me it is first order rate equation. In that first order rate equation, I should find out A minus X. Why should I find out A minus X? Because they have said how much time is required for 3/4 of decomposition, correct? So the leftover part I have to find out, isn't it? A minus X. So A I've considered as 1, because the total, if we consider as 1 minus 3/4. So I've got this answer, 1/4. And after that, I've substituted the values in this. Finally, I've got the answer. Yes, let us see, because most of the reactions are given under first order rate equation only, and some other questions which are which come under your Arrhenius equation, right? These two are mostly covered. Yes, let us come back and read. The thermal decomposition of formic acid is again first order rate reaction, okay, with rate constant of 2.4 into 10⁻³ seconds. Done. At certain temperature, okay, done. Calculate how long will it take for 3/4 of the initial quantity of formic acid to decompose. Okay, hope you would have watched the earlier videos. I have done the same question, exactly the same question with exactly the same units also. Everything, the data, the information, the question, everything is the same. Just watch that video. That is label in the 21st. Yes, this is your 21st video where I've done this numerical, I think the last part of that particular video. Please watch this video, you will get the information. So for solution, watch this video 22 or 21 under chemical kinetics chapter. It's the same, exactly the same question. Let us come back and do 2011 paper. There are two parts in this 2011 paper. Let us read this question. Basically, such questions are quite common in your board paper. Let us read. What did they give us? They've given us so that is nitrogen like N2O5, right? So nitrogen pentoxide decomposes according to the equation. Now this is the equation which is given to us. What do they give us? N2O5 gaseous state. It decomposes into NO2 and O2. Okay, this is the first order reaction, right? It was allowed to proceed at 40 degrees and below data was collected. Okay, this is the question given to us. They've collected, what did they do? They picked up this N2O5 and initial concentration was given to us, and they've also recorded the time. At what time is the concentration, how much is the concentration? Initially when the time was 0, the concentration of N2O5, M stands for molar concentration, that is mole per liter, it was 0.400. When the reaction proceeded at 80 minutes, the concentration was so much. Okay, this is the data given. What do they want us to plot? They want us to find K, right, rate constant with units. Okay, done. Then they've also given what will be the concentration of N2O5 after 100 minutes. I should also find this, and I have to calculate initial rate also of N2O5. Simple. As soon as such question is given to you, what should you do? Basically, try to plot a graph with the given data. Yeah, when you plot a graph, suppose what do I take? I'm going to take the concentration on the y-axis and pick up time on the x-axis. Done. Now let us see the minimum value here. The minimum value is 20. So start here, this one from 20. Let range it, the maximum is 80. So range it till 80. Now on the y-axis, when I pick up, the minimum value is 109. So I've started from 0.1. Yeah, 0.1. Then the maximum value was 0.4. So I ended till 0.450. So plot the x-axis and y-axis and start plotting. For example, if I take this at 20, now at 20, how much is the value? 0.28. Let it be rough, but at least mark it approximately, at least because you very well know how to mark, isn't it? For 20 it is 0.289. For 20 it is this is 0.25, there's 26, 27, 28. So this is a point. Like that I've marked for 40, I've marked for 60, I've marked for 80. Then when I've joined, I've got a graph like this. Yes, done. After that what should you do? Take the same tabular column. You will be given a logbook in the exam. Yes or no? You write the same data. Now you're going to find out the log value of the initial concentration. That means you're going to take your logbook and just find out log 0.400. Just 40 and 0. Find the log. Find the log for 289. Find the log for 209. 151. 109. You'll be getting the values like this, right? Directly please apply all the three numbers. You'll be getting log values. Record all the log values and keep it. Why did I do that? I'll tell you. After noting the log values, now you're going to plot a graph between time and log. Log will be on the y-axis, time will be on the x-axis. So this is your time scale. Then now start plotting at 0, 0. Now what is the minimum thing? Minimum is, okay, the origin is 0 and it's starting from 20, maximum of 80. 20 and maximum of 80. Here in the concentration, the minimum was, if I observe, I think, yeah, it is 3.39. So I started from 0.30. I went till the maximum, that is 0.96. The maximum 0.96, so 0.7, 0.8, 0.9, yeah, till 0.1. I've gone till 0.1 because I have to mark 0.96. Now start marking. For example, if I pick up 20, what is the log value which I've got at 20? I've got 0.53. Now this is 4, this is 5, this is your H20, it is 53, correct? Like that, I've marked for 20, I've marked for 40. It is not approx, it is just basically an approximation only. I have not marked it to the scale. 40, then 60. Okay, let me mark this down. 60, and this is 80. Okay, this is your 80. So I've marked for all the points. Then I've joined all the lines. This is over. Now, what should I find out? First I have to find out the slope, because I very well know for the first order rate equation, from the integrated rate equation, from the first order integrated rate law, we've already got the slope. Please check that video where I've shown you how to get the slope from the integrated rate equation. From that, I've got a slope, negative slope. You'll remember that where I've got it as minus k by 2.302. This is the basic slope which I've got for first order. Now, you are going to compare between this slope and this slope. Join any 2 points, not a problem. Suppose if I'm picking up this, yeah, these are all minus values, isn't it? Minus. So what do? Join these 2 points. Suppose if I'm taking this 70 and I'm going to take this 60. Yes. Now what happened? Now when I observe these two are the points for the concentration, and when I drop this down, yeah, if I should tell you perfect, if you drop this down, this is 40, isn't it? 20 and 40. So write down minus 0.7 minus of 0.6, isn't it? Two limits. Below we have 40 minus 60 limit. So when I solve this becomes minus 0.1 by 20. This is what is your slope. Now one slope is this from the log value, one slope is this. Now let us compare these two slopes. I hope you have understood. I picked up 2 points because straight line, on the y-axis 2, on the x-axis 2, and I have got y by x. Yes, I've solved it and I've got this answer. Now what do? You're going to take this slope, yeah, compare it with that. What is this particular thing? Minus 0.1 by 20 actually is equal to minus k by 2.303. Correct. So this and this gets cancelled. So I can easily find k. I can find k. How do I find k? Is equal to 2.303 into 0.1 by 20. I'm almost about to do this k, right? Isn't it? Now when I solve this, I get an answer of 0.01151. Correct. Now I can still write this 1151 as 1.151 into 10 raised to the minus 3. So for the first order rate equation, what is the unit? Unit is minute inverse or time inverse. Correct. So I have done the first one. How much is the answer? How much did I get? I got an answer of 1.51 into 10 raised to the minus 3 minute inverse. The first part is over. Now I have to do the second part. So for the second part, what should I do? They've asked me to calculate the rate equation for the second one, that is what will be the concentration of N2O5 after 100 minutes. Okay, I have to calculate what is the formula for first order. First order is K is equal to 2.303 by T log of, now in this case it is initial, that is N2O5, isn't it? So write directly N2O5, the initial concentration, divided by N2O5. I have one particular T, a particular type. Now what should I find out? I have to find out the concentration of N2O5 after 100 minutes. So after 100 minutes I am going to write that value of T here. What do I get? How much did I get for K already? I've got, how much is the answer which I've got here? It is 1.51 into 10 raised to the minus 3 is equal to 2.303 by, how much is the T value they've asked us? 100. After 100 I have to find out. After 100 log of, how much is N2O5 concentration given to us initially, because this is initial concentration. So write that. It is 0.400 divided by, I have to find out N2O5, isn't it? Yes, done. Now take this N2O5 out or pick this whole log out, anything, not a problem. When I take out that N2O5, I get a constant or answer of, this is the time T, I get an answer of 0.357 molar. Please calculate it. You have to find out N2O5, that is what they've asked. Now my part B is also over. How much did I get? I got an answer of 0.357 molar. Done. I have to do the last one. Calculate the initial rate of N2O5, they said. Okay, let us erase the second part and come back to the third part. This is your third part. What should I calculate now? Initial rate of N2O5. So I have to go back to the rate law. R is equal to K into N2O5. How much did I get K value? I got it as 1.51 into 10 raised to the minus 3 into, what is initial concentration of this one, N2O5? Because they said initial, pick up the initial value 0.40. When you solve this, you get an answer of 4.6 into 10 raised to the minus 4 second inverse. This is your sum. This is how we are going to do. Careful when such questions are given you. Try to draw 1, 2. This is a question for 3 marks. You are going to solve it showing graphically both the data, Go step by step, one after the other, numerical, and write. Please mention the units also. Let's come back and do the 2012 paper. Now this is your first part of your 2012 paper. Let us see this question. They've given us, I think this is also one of the questions which I've already done in your numericals, right? Watch the videos for that. Now they said a reaction is of second order with respect to a reactant. Okay, it is a second order reaction. How is its rate affected if the concentration of the reactant is doubled and it is reduced to half? Easy. They said second order reaction. So second order means the number of reactants. Suppose if I take as 2A, right? That is the two reactants 2A, and it's giving us some product. So now this is your second order reaction. Done. For this particular thing, what did they say now? How is it the rate affected when the concentration of the reactant is doubled? That means if I say rate, okay, they said, what did they say? Concentration is doubled, right? Concentration is doubled. I have to use this condition now. So write the rate of this reaction. Rate is equal to K raised to the power of 2 because it is a second order kinetics. Done. Now they said it is doubled. So rate is equal to K 2A square. Indirectly, rate is equal to 4K A square. A raised to the power of 2. So how many times did the rate increase? The rate has become 4 times. No? Rate has increased 4 times. Look here, 4K increased 4 times. You are supposed to write this in words like this. This is what the examiner expects you to write. Let us come back and write. They've given it is reduced to half. Simple. The same rate of the reaction, it is reduced to half. So it's already A raised to the power of 2. Reduced to half means, isn't it rate 1/4 time? Simple logic, right? 1/4 times. This is what is a change. This is what you have to. Rate becomes 1/4 times of a particular thing. Yes. So let us come back and solve this 2012 question. Now what did they give us? The reaction N2 plus O2 gives us NO. Okay. Contributes to air pollution. Okay, fine. Whenever a fuel is burned in air at a high temperature, that is 1500 Kelvin, rate constant was found to be so much. Okay. Suppose in case of N2, the rate constant is so much and oxygen is 0.20. What should I calculate? I have to calculate the concentration at equilibrium constant. Okay. Let us first write the equation. Given data. Right. So this is N2 gaseous state, this is oxygen gaseous state which is in equilibrium, and you get NO gaseous state. Basically when the time is 0, initially I have started the reaction. Now the concentration of this, let us assume the concentration of this is 1. Simple. And the concentration of oxygen also as 1. Now this will become 0. Initially T is equal to 0. Yes, still the products have not formed. Now when T is equal to some T seconds, now the reaction has started proceeding. Now what will happen? This particular one, this reactant, okay, now the product formation starts increasing because the reaction has proceeded forward. So this becomes X. Suppose if I assume, how many times is it? 2X. Correct. Then what will happen to this? Now a part of it is decomposed. This becomes 1 minus X, and this also becomes 1 minus X. Hope you understood this. This initial is 1. This is also 1. And when T is equal to 0, this is obviously 0, isn't it? It has not formed. Then as the reaction proceeded, I am considering this a part or the product as X value. How many moles? 2X. Correct. Now when I come back and see this, X part has already decomposed, that minus this, the leftover part is N2. Now at equilibrium, what will happen? Observe, the rate is equal to concentration into C, that is C into 1 minus X. I am taking it as concentration. This also becomes C into 1 minus X. Correct. So the concentration, because I have to find out this, they have asked me to find out the equilibrium constant. So that into 1 minus X is here. Now let us solve this whole thing. What do I get? What is the data which is given to me? Data which is given to me is, they have given me the concentration of N2. How much is N2 given? 0.80 mole per liter. How much is oxygen given to me? 0.20 mole per liter. Okay, let us not write numbers because already per I wrote. What else is given to us? K is equal to 1 into 10 raised to the power minus 5. Now, see in these two reactants, what is the limiting reagent? So what is limiting reagent? Basically, the reactant which is consumed the most is a limiting reagent, isn't it? Now, because without limiting reagent, I can't find the C minus X value. I don't know what is X, isn't it? So let us find out this X value first. So when I compare these two, oxygen is a limiting reagent. So we will write oxygen is a limiting reagent. Okay, now I can use that oxygen value, isn't it, in this 2x. So 2x is equal to 2 into 0.20, it is equal to 0.40 mole per liter. Okay, now I've got X value. I can easily find out C minus X, that is equilibrium constant, which they've asked me, this one and this value. Okay, let us write. Now what should I find out? I have to find out first at equilibrium constant for N2. So equilibrium constant for N2. Now when I write N2, basically what is this? It is C into 1 minus X, right? What do we get now? What is concentration of N2? It is 0.80 into 1 minus, what is your X value? 0.40. When I solve this, I get an answer of N2. For N2, I get 0.48 mole per liter, because they've asked me concentration, mole per liter. Right. Now, second thing, when I have to find out for chlorine also. So, find out for chlorine, equilibrium constant. Right. For chlorine, what do I get? C into 1 minus X. Now, observe what is C here for oxygen? It is 0.20. Now, careful. Now, part of it, right, already this is gone, isn't it? The limiting reagent has gone. The leftover, if I speak, right, the leftover is 0.2, so 0.2. When I try to solve this, the leftover part, what do I get? I get Cl concentration is equal to, I think this is 0.2 into 0.80. So I get an answer of 0.16, 8 to the 16 mole per liter. This is let us come back and do the choice question of 2013. Right. Now, let us read the first question, part A. What do they give us? For first order reaction, show that the time required for 99% completion is twice the time required for 90% completion. Okay. It's the same question which I've already done in one of the video. That is, I think, yeah, it is video number 22, right? Video 22, which were numbered as 22. Please watch that. It's the same in that. What is the difference? There it is given 10 times the time required. Here it is given as twice the time required. So please go to that video. The concept will be clear. So for that particular thing, please watch that video. Done. Let us come back to the next question. So I'm doing the part B question. The rate constant of a reaction varies with temperature, right? And the temperature T, okay, according to the equation, this is the thing, right? The rate constant and temperature related. Now, inversely, right? Now, let us see. Now, they've given EA as activation energy. When a graph is plotted, log K versus log T, a slope so much was obtained, it seems. What should I find out? I have to find out EA. Okay. So whenever such questions, graphical questions are given to you, try to first draw the graph, then go to the calculation part, so that you'll get the complete 3 marks in that particular numerical. Now let us see. This is your equation which is already given to you. So what do they say? They said when a graph is plotted, log K versus 1 by T. So this is your y-axis. Yes. Now, this is your x-axis. Now, according to the formula for a straight line graph, y is equal to mx plus c, isn't it? Let me write here. X mx plus c. Yes. Now, observe carefully. On the y-axis, you have here log k. Log k on the y-axis. On the x-axis, you have 1 by t. 1 by t. Done. Now what is this here? M is the slope, isn't it? This is your slope part. What are you getting in the slope part? You're getting a negative slope. That means when you're drawing a graph, the graph should be negative. This is what is showing you, minus EA by RT. M is the slope, isn't it? Now what is C here? C is a constant, Arrhenius constant. This is your constant. We are not. Now slope is, this is your part minus EA. So right here, slope is equal to minus EA by 2.303 R. But what is slope given to us here? They've given a slope of minus, this value they've given is equal to minus 4250K. That is what they've given us. So try to solve. Now your first part is over. Try to solve the second part. Minus EA by 2.303 R is equal to minus 4250. Because I have to find this EA, isn't it? This minus and this gets cancelled. So what is EA? EA activation energy is equal to 2.303 into R. The gas constant value 8.314 into 4250. When I solve it, I get this answer. Multiplication 81.3753 kilojoule per mole. This is your answer. This is how you're going to solve. Graphical questions, remember, they expect you to draw the graph and show the slope. This is how it will be in the board key. This is what they want you to also write. Please note, watch this video also. The same question again repeated. See this 2013 paper. In this particular paper, basically in most of the papers, what do? They either give a 2 marks question initially in your first short answers, and they give you a 3 marks question later. But in sometimes what happens is they're going to pick up the whole, the total of 5 marks in one question only. How? They're going to divide it into A and B, and in the A part they'll give you 1, 2, 3. Right? This is your 3 marks, and this is your 2 marks question. Right? Like that, they'll club together also and give you a question. So let us see the question. 2013 paper. So a reaction is second order with respect to A and first order with respect to B. Okay. First, what should I write? Careful, because you all the 3 marks, you have 1 mark. Try to write all the 3. Even if you just like by chance, if you don't know the answer, try to write the nearest answer at least. Okay. So what is a differential rate equation? Okay, I'm going to write the solution first. What do they say? I have to write the differential rate equation with respect to A and B. So as I very well know, rate is equal to K into concentration of A and concentration of B. So what did they say? They said A is second order kinetics. So the order will be 2. And B is first order kinetics, so the order is 1. So the first question first is done. I'm done with the first one, differential rate equation. I'm coming back to the second one now. What did they ask me? How is the rate affected on increasing the concentration of A 3 times? Now to the same reaction, they increasing the concentration of A 3 times. So this becomes 3A square into B. Correct? Yes. Now it is 3 times the rate has what will happen to the rate if this concentration has become 3 times. So how do you write this? You write this as basically 9K, isn't it? That's it. So this becomes A square and B. How many times did it increase now? Observe carefully. Rate has increased how many times? 9 times. So you will write rate has increased 9 times. Done. Let me come back. I'm also done with the second one. Let me come back and do the third one. How is the rate affected when the concentration of both A and B are doubled? So A and B has doubled. So A, again pick up the same thing. K, A has become 2 times and B also has become twice, doubled. So what do you get here? This rate becomes, now I can write, this is 4, isn't it? And this is 2. So you can write 4 into 2K and A square and B. Try to mention separately so that it's clear for the examiner to allot you marks. So how much it becomes? Now this becomes 8 times, isn't it? So what do you get? You get R is equal to 8K and concentration of A raised to B and concentration of B is like this. So this is your 8 times. So how much is the rate increased? Rate has increased 8 times. This is how you should write. Here the rate has increased 9 times, here the rate has increased 8 times, and you'll finish up your answer. Yes, now done. Let us do the next part of the same question. I've completed the first part. Let me do the B part now. Yes. So when I come back to the B part, first let us read what is given to us, and then we'll start. So let us write the given data. So what is given to us? They've given us a first order rate equation, correct? So first order rate equation, 40 minutes is given. T is 40 minutes. How much is decomposed? 30% is decomposed. I have to calculate T half for this. Done. Nothing is given to me, but I have to calculate the half-life period, and I have to start with this formula. First, write first order rate equation. What is first order? K is equal to 2.303 by T log of A by A minus X. Yes. Now, I have this quantity 40 minutes. I have to find out the left out quantity. They have asked me first order rate reaction, calculate for this reaction, right? We are not bothered about this. I have to calculate how much is left out. This is what is the quantity left out, isn't it? So substitute K is equal to 2.303 by 40 minutes. Now, there's small logic here. A by, when they said in the reaction 30% is decomposed, they said at this particular time. How much is left out? 70% is left out, isn't it? So 70 by 100 to 8. That is the logic. Yes. So done. So what should I do now? When you solve this, 2.303 by 40. Now this is log 1 by. Yes. You almost get an answer of 1 point. Yeah. If you solve this, this becomes 0.7. Yes, done. Now, when you solve this, you get an A and A gets cancelled. When you solve this, you get an answer of K is equal to 2.303 by 40 log of 1.428. They've already given this value. So, how much is log of 1.428 given to us? 0.158. So substitute that value here and substitute this 1.428 value. This is here given. Once you substitute and solve the whole thing, yeah, you get an answer of 0.00891 minute inverse. Okay, this is what your answer. I've got rate constant. I've not got T half now. So I'm calculating. This is your A part of this question. Let us do the B part of this. Second part is, we very well know for T half is equal to, for first order reaction, 0.693 by K. Yes or no? Now I've already got K. T half is equal to 0.693 by T half, K is 0.00891 minute inverse. This is what we have got. Answer after calculating. Yes. Now final answer, when I solve this, I get an answer of 77.78 minutes. Because this minute inverse, when it goes above, it becomes minutes. This is the formula. So let us come back and see. They've given us first order rate kinetics. I have to find out T half. Then I've written the formula here. I very well know they've asked me to calculate T half for the leftover thing, isn't it? I have to calculate how much ever reactant is left over. 30% is used in decomposition, the leftover part. So out of 30, the leftover is 70 by 100. This, you should not write this because initial, we have to find out this quantity. So I have solved this. So this becomes 0.7. Once this becomes 0.7, 1 divided by this 0.7, already they've given in the answer 1.428. Use that 1.428 here. So 1.428 log value is so much. Substitute that log value here and multiply the whole thing. You get this answer. K, I've got K. Now come back and do the T half part. T half is equal to 0.693 by K. Use that value here. You get 77.78 minutes as you utilize it. So 77.78 is a half-life period for this reaction. Let us come back and solve 2014 paper. So such basically in chemical kinetics chapter, you'll be given, most of the numericals will be given in this tabulated column, means the data will be given in the tabulated column. But before we start the question, let us read the question. The following data was obtained during first order thermal decomposition of thionyl chloride. Okay, right. So they've given us Thionyl chloride, right? What do we remember? We've already studied about thionyl chloride, gaseous reactants, isn't it? It's going to dissociate into your sulfur dioxide gas, gaseous reactants, right? At constant volume. So as I said, gaseous reactants, just observe the data given to us. They perform 2 experiments. In those 2 experiments, the time interval observed is 0 minutes. The pressure or the partial pressure exerted by that particular the reactant is 0.4 atmospheres. At 100 seconds, it is 0.7 atmospheres. Done. So basically, whenever they give you gaseous reactants and they clearly mention thermal decomposition of that particular thing on heating, right? Then remember, though it is first order reaction, you have to write a formula which is relating the gaseous reactants. What is the formula for such gaseous reactants? So I'm writing that also for gaseous reactants. Remember this formula. Normally it is rate constant K is equal to 2.303 by T, correct? It is log of, what do we write normal reactant? It is A by A minus X, isn't it? But here for gaseous reactants, you're going to write a formula P naught by 2 P naught minus PT. Okay, I'll tell you what are P naughts and what is PT. Remember this formula first for gaseous reactants. Yes, in the above particular numerical, we are given 2 things. First, P naught. P naught is this atmosphere, initial P naught. And your PT is this final, right? So the partial pressure P naught is 0.4. Let us write the data. P naught is equal to 0.4 atm. Your PT is this. PT is 0.7 atm. Done. What should I find out? I have to calculate rate constant, isn't it? Yes. So rate constant, done. So T is already given. T is equal to 100 second inverse. Simple. Now substitute in the formula. K is equal to 2.303 by T is 100 second inverse log P naught is how much? 0.4 divided by 2 into 0.4, because it is P naught value. How much? It is minus of PT is how much? 0.7. So when you solve this, what do you get? You get K is equal to 2.303 by 100 into log. This becomes 0.4. Yeah, this will become 4, isn't it? Yes. Now basically when you solve this becomes 0.4 by 0.1. When you solve that, it will come to point. Okay, if you want, I'll write that also. Log by 0.1. Now what do you get? K is equal to 2.303 by 100 into log 4. So what is log 4 value given to us? It is already given as 0.6021. Now write K is equal to 2.303 into 0.6021 divided by 100. You get an answer of 1.39 into 10 raised to the minus 2 second inverse. That's it. This is what they want to find out. So to find out that, remember, you have to see whether it is a gaseous reactant or a normal reactant and write that formula for the gaseous reactants, the first order kinetics, substitute the value and you'll finally get the answer. Right. So let us come back. This is one more question of 2014 paper. Basically, you have 5 marks, as I said. 2 marks is your short question which is given, and the 3 marks is a numerical. So let us read this question. So what did they give us? For a chemical reaction, a reactant giving us product. So observe carefully. This is only one reactant. Okay, let us see the variation in the concentration of the reactant versus time. So they've drawn a graph here and they've already plotted the points, and they said predict the order of the reaction and what is the slope of the curve. No data is given, nothing is given. So remember, basically when I taught you integrated rate laws, I've already mentioned whenever you're learning integrated rate laws, first important thing is learn the rate law. After that, learn the units. After that, learn the graph. This is where it will be useful. Every kinetic reaction you have to plot it. Finally, you have to show it in the graph. Learn the graph also perfectly. So basically, when we see this particular thing, you're getting a negative slope, isn't it? So negative slope, from which one are you getting negative slope? Zero order reactions, remember? So the order of the reaction, so what do they ask us? Order is 0. For zero order reactions, you get negative slopes. Let us see. So what is the slope of the curve? So they want you to prove whether it is zero order or not. Okay, let us see. For a zero order reaction, what did you write? K is equal to R naught minus RT by T, isn't it? This is what we have written. Now let us see. Just cross multiply. KT is equal to R naught minus RT. Fine. Now, your, okay, RT, if you don't know R also not a problem. Okay, we're getting confused. R. Get this R on this side. R is equal to, plus becomes minus KT plus R naught. Right, now how is this looking? Y is equal to mx plus C. Initial concentration, yes, R naught, that is a constant. Now observe, on the y axis what do you have? R. On the x axis what do you have? T. And what is the slope now? This m is slope, isn't it? What is your slope? Minus k. That's it. Simple. As you have shown already, you have shown this here. You have proved it by writing the equation. And there, y-axis R, x-axis T, and your slope, that is M, is your slope. So negative slope. That's the reason you're getting this graph. So write your answer, prove it, and write slope is minus k, and put it in a bracket. This one also put it in a box so that your answer is complete. Yes, let us come back and do one more question. This 2015, that is, they're given a choice. What do they do? They've given A, B, and again or, and again A, B. So this is the B part of your question of 2015 board paper. So let us see. They've given us this particular thing. What do they give us? They've given data is T is 23.1 for 50% completion. T, again I have to calculate time for 75% completion. What did they get? First order reaction, this at 23.1, 50% of the reaction is completed. Then I have to show what is the time when 75% of the reaction has to be completed. So simple, they've given you first order. So write the formula for first order. What is the formula? So write formula and start like this. K is equal to 2.303 by T log concentration of R naught by R, isn't it? This is what we have derived already. Yes. Now what is there? Do we have K here? Because I have to find T, isn't it? I can't, the two can't be unknown. One should be known, isn't it? So I have to find T. So find out K first. To find K. So what do we know? K is equal to, okay, T half, we'll start like that. T half is equal to 0.693 by K. Yes, so this is already given, right? So I don't know K, but I still have T half, right? I can exchange. So K is equal to 0.693 by T half. Can I write? Now substitute the value. Well, what is this 0.693? How much is T half given? Let us assume 23.1 minute. So when I solve this, I get an answer of 0.03. Done. Now I can substitute this 0.03 into this, label this first. Now come back to the second one. Now what do I have? I have this formula 0.03 is equal to 2.303 by T log. What is R naught initially? They have given me R naught initially should be 100%, isn't it? So 100 divided by, for which one should I find out? I have to find out for 75%. So 100 minus 75. Correct. So you get 25 here. How does this look? This becomes, if I solve this, if I solve 0.03 is equal to 2.303 by T. Now log 100 by 25. Now this becomes how much? 25 ones are 25 fours are. So it has become log 4. Now what is log 4? It is 0.6021 log 4. Yes. I am going to get, just send this T above and get this down. What do you get? T is equal to 2.303 by 0.03 log 4. So log 4 value is already given. When you multiply, you get an answer of 46.22 minutes. That's it. So simple thing, you have to remember, one, write the given data, write the formula. After writing the formula, see what is not given, what is related, which is the unknown quantity first. After writing the unknown quantity, find whether you can relate it with one more formula or not. After relating with one more formula, substitute the values you get and finally write the units. Right. So let us come back and solve the 2015 paper. So what is given to us? What is the rate of a reaction? Write two factors that affects the rate of the reaction. Okay, we have already done a video on this. So what is rate of reaction? Basically, it is decrease in concentration of the reactants and increase in concentration of the products per unit time, right? Please watch the video. I have done the first or second video of chemical kinetics. And what are the factors which affects the rate of the reaction? This also video was done on this topic also. So what are the different factors? We said nature of the reactant, concentration of the reactant, effect of temperature or temperature factor, effect of catalyst. Then we also said physical state of the reactant. They have asked you to write any two. You can pick up temperature and as I feel concentration of the reactant and temperature. These two would be enough. So let us come and solve the numerical. Please watch the video for the first question properly. Yes. So the rate constant of the first order reaction increases from this to this. Right. So they've given me rate constant. What do we give us? Write the given data first. They've given me K1. How much is it? 4 minus 2. Now, and how much? K2 is equal to 8 into minus 2. When the temperature changes from, so they've given me two temperatures here. Yes. So what did they give us? T1 is 27 degree and T2 is 37 degrees centigrade. What should I calculate? I have to calculate EA. Right? Now, as soon as this is given to you, it's simple, Arrhenius equation. But remember, as soon as this temperature is given to you, try to add your 273 Kelvin to both. 273, that's important. Then only it will get converted 300 degrees and this becomes 310 degrees. Correct? Yes, done. Now my data is ready. I'll apply in the formula. What is the formula? We have done log K2 by, this is your Arrhenius formula, Arrhenius equation formula. I have done a video on Arrhenius equation formula. Please go through the video and then try to solve this and learn this. K2 by K1 is equal to 2.303. Yes. So what do we write? 2.303. Then we have written your R, isn't it? Yes. Yeah. Then we have written your temperatures. And what do we write? No, what did I write? I did a mistake here. I have to write EA by 2.303 R. Yeah, 2.303 R. Correct. Then we are here by T1, T2, T2 minus T1. This is what I got, right? I'm sorry, I did a mistake here. Yeah. So this is your basic, we have derived this from Arrhenius equation. Now apply the data from that. Now, what is log K2? Your K2 is 8.8 in 10 to the power of minus 2. What is K1? 4 into 10 to the power of minus 2. Yes, is equal to EA. I have to find out EA. Then into 2.303. What is our gas constant, isn't it? How much is gas constant? 8.314 joule Kelvin inverse mole inverse. Yes. Now put the bracket, close the bracket. Now what do we have? T2 is your 310 minus your T1 is 300 divided by T1 into T2, 310 into 300. Simple. Now that is solve the whole thing. This and this gets cancelled. Correct. Now here 4 ones are 4 2. So you get log 2. Correct. Now is equal to EA by the whole thing here 2.303 into 8.314 joule Kelvin inverse mole inverse. Now this comes to your 10, isn't it? 10 divided by, I think, yeah, it is 93 zeros. Now I can easily find EA. EA is equal to cross multiply log 2. What is log 2 value given to us here? They are given 0.3010. So 0.3010 into 2.303 into 8.314 into 9300 divided by 10. Simple. Yes. So what do I get? When I solve this, I get an answer of 53598.5 joules, because this is your unit for activation energy, EA, energy of activation. That's your unit. So please note it. Simple. Write the given data, apply it in the formula, and finally you get an answer for EA, that is activation energy measured in joules. So let us come back. This is actually 2015 paper only, but it is a choice question given in 2015. Let us read the question, solve it. So So for a reaction, A plus B is giving me products. Okay, there are two reactants here. Okay, then the rate is given by R is equal to K, rate is equal to K into the concentration of A and into B raised to, okay, fine. How is the rate of the reaction affected if the concentration of B is doubled? Simple question, let us see. So what is given to us? Rate is equal to K, A and B square. Right, so let me write solution. Now, this is your first reaction. Now they said in the second one, rate of B is doubled. So I'm going to write this as rate 1. Let me assume this as rate 2. So now what did they say? Rate of B is doubled. So 2B square. Let me name this as 2 because it is doubled. Right. So initially, how much was the rate? It was only 1, right? Here it has become double. So what happened to the rate now? Rate has increased. It has become 4B square. So now, so how many times did it increase? Yes, compared to this has increased how many times? 4 times. So rate has increased 4 times. That's it. This is what the examiner wants you to write. Simple. This is nothing. This is doubled. So 2 square is 4. Done. So I've done the first one. Let us do the second one. What is the overall order of the reaction if A is present in large excess? Good. Have you already given me the clue? They said in that reaction A plus B giving me products, A is in excess. If a quantity is in excess, as we have studied in pseudo first order reaction, if a particular reactant is in excess, the concentration of that particular reactant doesn't change. So let's write concentration does not change. So rate of the reaction does not depend on this. So let us write if quantity is in excess, rate of the reaction does not depend on that. Remember this. If they've given an excess, forget about that. Now, what is the overall order? When I say overall order of the reaction, what is order? Basically, the addition of plus and this, isn't it? This one and this coefficient. But already this is, we're not considering this. So, what is the overall order? Only you consider for B. So, overall order is 2. This is your answer. So, my students, let us do the 2016 board paper. So, we've already done the 2017 board paper and please be careful. As I said, chemical kinetics chapter, it includes or you'll be given the numericals only based on your theory which you have studied. So, let us come back and solve the 2016 paper. Yes, let us read the question. For the first order thermal decomposition. Okay, so this is the first order rate equation given to us. The following data were obtained, right? As soon as I see this reaction, I can clearly say there is only one reactant participating in the DS, that is rate determining step. So it is a first order rate equation. Done. What should I find out? I have to find out rate constant K. Okay, and some data is given to us. So what are you observing here in this reaction? All are gaseous products, right? Yes. So when they are gaseous product, obviously it is understood they exert certain pressure, isn't it? So that pressure is given in this particular context, that is they exert certain partial pressure on the surface, isn't it? So that pressure is given to us in the term measured in atmospheres. Okay, so what am I trying to explain? Let us see. As soon as such question is given to you, first they said it is your first order thermal decomposition. So you have to find out, first write the formula. So what is the formula you require? K is equal to 2.303 by T log, right? So basically what did we study in first order rate kinetics? It was A by A minus X, isn't it? Normally, but here what are we going to study? Instead of this, we are going to write a formula called individual or partial pressures by partial pressure minus X. Okay, this is the formula for such gaseous reactants. I'll explain what it is. Now, as soon as you write the reaction, now start your answer. Now pick up that C2H5Cl, your gaseous state, your in the presence of H nu, sunlight, is going to give you C2H4 this plus HCl gas. Right, done. Now what happened? Initially, when the time was 0 seconds, the pressure exerted by this particular one, when it was initially, it was the pressure exerted by this was how much? 0.30 atmospheres. Okay, so what do I write? I write Pi is equal to the individual pressure, the partial pressure exerted by this is 0.30 atmospheres. Right, now what is the time here? T is equal to 0 seconds. Yes, now observe. Will there be any pressure exerted by this? No, because they have not yet decomposed, isn't it? It has not yet decomposed at T is equal to 0. Done. Now gradually come back. Now at T is equal to 300. Yes, now what will happen to this partial pressure? This goes on decreasing, and the certain amount of pressure exerted by this particular gaseous product, and this also, isn't it? Now at 300 it just started proceeding forward direction. So now the pressure exerted by this, I'm picking up it as X. This also I'm picking up it as X. Yes, now this is X and this also is X. Now what will happen to the initial reactant concentration, or partial pressure? It becomes Pi minus X, isn't it? Yes, right. This is 1. This is also 1. This is also 1. Now, let me solve the whole thing. Now, for what should I do? I know what is Pi. What is Pi for this? 0.3. I have to find out this quantity. So I'm solving the whole thing to find this X quantity. What you take? P total. Now the total pressure exerted is equal to Pi minus X plus X plus X. Correct? Is equal to P total, right? Now just see, plus X and minus X gets cancelled. What are we left with? We are left with P total is equal to Pi plus X. Yes, now what is P total given to us? P total given to us is 0.50. 0.50. Right. What is Pi given to us? Initial Pi is given to us as 0.30 plus X. Now X is equal to when this goes the other side, 0.2. Correct? Yes, now I have got X value. Now what should I find out? Once I have got X value, I can substitute this X value. Now let me label this as step 1. Now let me come back to step 2. In step 2, I have got X value. So can I find out this X value here? So what is now since X is equal to 0.2, now substitute this value in this Pi minus X, right? This is what I have to show. So what is Pi now? We have got Pi as 0.3. 0.3 minus 0.2 is equal to 0.1. Now I've got everything, isn't it? Yes, all the data is with me. I have solved it. I've got 0.2. I've taken the same value, substituted in this, and I got 0.1 ATM. That is over. Now, okay, ATM. Now substitute in this data. So what I'm going to do, I'm going to erase this part now and observe carefully. So I'm going to solve this whole thing using this. I'm going to apply this. So what is this? What should I find? K. K is equal to 2.303 by T. How much is T? I've given in this one. T, I think I've got 300, correct? Into log. What is Pi, which I initially have? Pi I have is 0.3 divided by what is Pi minus X? We've got 0.1. Correct. So what will this become? K is equal to 2.303 by 300 the log 3. Already this log 3 value is given to you. How much is given to you? Log 3. Substitute that value of log 3. That is 0.4771 is given to you. So let us write K is equal to 2.303 by 300. Your log 3 is 0.4771. Once you solve this, you get an answer of 0.0037 second inverse. That is your unit for your first order rate equation. So once again, let us see. First, as soon as such question is given to you, if it is given as first order, try to write that formula. And here what happened, they've given us gaseous reactants. So instead of A by A minus X, I have written the partial pressure reactants. I have taken that. So initially, this is your basic reaction, isn't it? So what did I assume? At 300, T is equal to 0, initial partial pressure exerted is 300. Sorry, 0.3 atmosphere, which is given. But as the time proceeds, this also increases. This also starts inserting or showing partial pressure. This also starts showing partial pressure. So that whole thing I've subtracted because Pi is the total Pi minus X. After that, I try to find out from this formula PT is equal to total of everything. So Pi minus X plus x, cancelled it. I'm left with pt is equal to pi plus x. Done. Now pt, what is pt given in the table? Pt given in the table is 0.5, pi given is your 0.3 and plus x. I got x value. I took that x value and I substituted in this formula. I got 0.1. I took the same thing and I substituted in the formula. Log 3 is already given, so I've got an answer of this. Yes, so we've already learned about collision theory. So what do we say in collision theory? Every collision, suppose if you want the required product, the collision should be effective in nature, isn't it? So when will this be effective in nature? It should have threshold energy, it should have activation energy, and most important thing, it should be properly oriented, correct? So orientation should be perfect. So let us see that concept in collision theory. Now we have already studied in SN2 mechanism. Yes, fine. In that reaction, what do we see in this? Here, suppose if I have an alkyl halide, so right, this is one H, your hydrogen, and Br. So what is this? Now this is your alkyl halide. Now this alkyl halide is going to undergo the substitution, nucleophilic substitution reaction. So you're introducing a nucleophile to this, right? Now the condition is, suppose if this is properly oriented, and if it is not properly oriented according to collision theory. Now important thing, suppose if it is improperly arranged, improper orientation. How is this improper orientation? Orientation means arrangement. Now suppose this OH, if it is attacking from this direction, yes, no, do we expect products? No, isn't it? Most important, OH minus has to attack from back. In the SN2 mechanism, what is the orientation? It should backside attack, isn't it? Backside attack, correct? So if OH is attacking from this direction, there is no product formation. No product is formed because the orientation is not correct. But here, if the OH is attacking from here, proper orientation, yes, so we call it as proper orientation. So in proper orientation, if it is attacking from here, first important thing, it's going to form a transition state. How? This carbon is in center, hydrogen 1 above and 2 hydrogens below, yes, and this is going to form a transition state between one nucleophile and one nucleophile, one OH here, one Br here, isn't it? Correct. Now this is called transition state. Now this further breaks up into, there's a cleavage of the bond here, and what do you get? COH at the back end, which we have got your H and H and your Br minus. Now this already broke the bond, isn't it? So your alcohol. So the required product is formed only when there is proper orientation of the nucleophile. If it is improperly oriented from this side, you will not get the products. So let us come back. We have done the chemical kinetics chapter. We have all done the numericals in between along with the theory part. So please practice all the numericals along with the theory. So let us start with the board papers. As I said, once the chapter is done, I'll be doing all the 10 years board papers. So this is going to follow till the month of February. As once we have done with all the board papers, it is easy for us to re-revise everything, like learn new links between the different topics of the syllabus. Yes. So I'm starting with the first numerical, that is of your 2017, that is your last year paper. Let us see how to do this. So 2017 paper, let us read. What did they give us? Basically your chemical kinetics chapter, you have zero order, first order, pseudo first order, isn't it? And Arrhenius equation. Most of the numericals are given either in the first order rate equation or on the Arrhenius equation. So this is again a first order reaction. Let us see. A first order reaction takes 20 minutes for 25% decomposition. Calculate the time when 75% of the reaction will be completed. Okay, so basically they've given this clue. Means this is where you have to start your numerical. So does write the given data. Now what did they give us? They've given T is equal to 20 minutes. When the time was 20 minutes, how much has decomposed? 25% has decomposed, right? So that means your A initially was 100%, then A minus X was your, this is your 25%. This is what is the data given. Let us come back to the next data. They have given one more. Calculate the time. Here I have to calculate the time when 75% of the reaction is complete. So A again is 100%. That is where your reaction has started. How much is A minus X? Given is, yes. Now I have two data left with me. I have to apply that data in your first order rate law. So what do you know? We already have derived the first order integrated first order reaction. What do we write? K is equal to 2.303 by T log A by A minus X. This is what we have written, isn't it? Now try to substitute the values for both and then we will divide the both. So finally what do I get? I have to get time. So applying this formula for this data. So what do I get? I have to find out time. To send this time on this side, T is equal to 2.303 log. Right. Now what is your time in the first thing? Your time given is 20 minutes already. Done. So next log A is 100% which is given, A minus X which I've already got 25. This is the first reaction. I have to apply the same formula for the second data given. So apply the same. In this I have to find out T is equal to, you have 2.303. Yeah. Now this is your K, isn't it? I have to write K. Right. K value is not given to us. So I've just mentioned K there. K log, and the second data given to us, A is again 100% and the amount of A minus X decomposition is 25%. Let us label this as second equation. Done. So we have got both the data separately. Now we are going to divide. Let us divide equation 1 by equation 2. Okay, because I'll just write it above here so that it's visible for you all. Right, now I'm going to divide equation 1 by equation 2. So equation 1 is 20 divided by equation 2 is T is equal to, again this is 2.303 by K divided by, again you have your 2.303 by K, correct? Now here you have log, yes, 100 by 25, yes, so it is 4 by 3 times 25 4s are and 25 3s are, and this is divided by your log 25 4s are, isn't it? Log 4, correct? Yes. Now this and this gets cancelled. What are we left with? We are left with 20 by T is equal to log 4 by 3 by log 4. If you solve this equation, and you can easily find T, isn't it? You solve this and find T value. I think you'll get an answer 6.3 minutes. Please note this. Try to solve this numerical, and the procedure is same. Given data, write the formula. Here for the formula, you'll be getting 1 mark, and for this equation, you'll be getting half mark. Again, for the second equation, you'll be allotted half mark. So 1, 2, and for your final answer, you'll be getting 1 mark. The total of 3 marks are allotted for this particular question.
Students, let us start off with the 2018 paper. Let's read the question. So here what did they give us? They said for the reaction A to B, the rate of the reaction becomes 3 times when the concentration of A is increased by 9 times. What is the order of the reaction? So it's a simple question. Let us write the whole data and then start explaining it. What did they say? There is a reaction A, it's getting converted to B. Correct, students? How much was the initial rate? Initial rate, if I have to write according to the rate equation, initial rate R is equal to K into A raised by N. This is a coefficient. Now let us give this as next. They said the rate of the reaction becomes 3 times when the concentration of the A is increased by 9 times. It seems this R has increased to 3 times. And the concentration of A has increased to 9 times. This is what they have given us. Right. Next, What did they say? What is the order of the reaction? Now, simple students, both are rate equations, isn't it? So I can divide. So I'll write this. Divide equation 2 by 1. I'm dividing equation 2 by 1. So what will it come to? It will come to 3r by r is equal to k into 9a raised n divided by k a raised n. Right, students? The common terms I can take it out to one side and rewrite the equation. How does it look? So r and r gets cancelled, isn't it? Right? This r and this r gets cancelled. So I'm rewriting the equation once again. 3r by r is equal to 9 raised to the power of n k. All the common terms I'm writing on one side. These are all the common terms, isn't it? Here I have written. So this and this gets cancelled. This and this, all these terms get cancelled, all constants. So this value becomes equal to 3 raised to the power of n. So I can write at the same basis 9. I can write it as 3 raised to the power of 2n, isn't it? Yes. So let us draw one line, students. Let us draw one line. So now equation is ready. So this becomes 2n is equal to 1. N is equal to half. Okay. Now rate of the reaction is K A half, and order of the reaction is, so half is the order of the reaction. That is what they have asked. No, what is the order of the reaction? So order of the reaction is half, students. Simple. Now let us see one more question of 2018 paper. What did they give me? A reaction is first order in A and second order in B. Write the differential rate equation. This is what they have given me. So let us first solve first point. What is this? First order in A and second order in B. So the differential rate equation is, let us underline this. Okay. So rate are, okay, first order in terms of A. So A. Second order in terms of B, they said. So what is this called, students? Differential rate equation, where you are equating the rate equal to the rate constant into the concentration terms. Right? So first order in terms of A, second order in terms of B. So both are done. What did they ask us? How is the rate affected on increasing the concentration of B 3 times? You are increasing the concentration of B 3 times itself. Let us take the equation. So in the second part, what did they say? On increasing concentration of B by 3 times. By 3 times. Nothing. You are going to take the rate equation again, right? So this is your second rate differential equation for B. How many times it is increased? 3 times. So it becomes 3 square. How much is it, students? 9 times. This is the concentration of B. And what was the next earlier one? Sorry, they said one more thing. Find out third one. How is the rate affected when the concentration of A and B both are doubled? So let us take that. Now concentration of A and B are doubled. Write down D A and B square, both are double, means this concentration of A is doubled, 2. Concentration of B also is doubled, 2 square. Total is 8 times. So this is the answer. Got it, my students? So simple, just we've done the square root of that. Now let us come and see 2019 paper. What did they give us? They said there's one more chemical kinetics here for numerical. The decomposition of ammonia on platinum surface is zero order reaction. Okay. If the rate constant K is given, okay, then how long will it take to reduce the initial concentration of ammonia from this quantity to this quantity? Okay. So first of all, what should I find out? I need to find time. How long is time? What is given? They said it is zero order reaction. Okay. So for zero order reaction formula we already know. First let us note all the data. What is there, students? They said initial concentration is equal to A naught. How much is given, students? 0.1 molar. Final concentration, how much they said, students? It is equal to 0.064 molar. How much is the rate constant given? 4 into 10 raised to the power of minus 3. Correct. Now, how long will it take to reduce? So, T value I need to find out. Now, they said it is a zero order reaction. So, for zero order reaction, already clue is given to us. We know that for zero order reaction, the formula is T minus K by K. This is the formula which we know. Now, substitute the values. How much was A naught, students? A naught was 0.1 initial concentration. How much was final? 0.064. How much was the rate constant value? So much. Then finally when I solve, I get an answer of 9 seconds. Simple as that. So easy. You need to just note the data and then substitute in the formula because they have given you zero order reaction, right? So substitute directly and get the time which is in seconds. So let us see the 2020 CBSE board sample paper which they have released. What do they give here? For a reaction, the rate law expression is represented like this. So there is a rate law expression which is given. What should I interpret? Interpret whether the reaction is elementary or complex reaction. Give reason to support your answer. So basically, is this reaction elementary or complex? So first of all, students, remember, as soon as a reaction is given to you, to know whether it is elementary or complex, first calculate the order. So copy the reaction. R is equal to K into A, B half. So 1 plus half, nothing but 3 by 2, correct? So what is the order, students? It is 1.5. Right? Fractional order we have got. So always remember, molecularity can never be 1.5, correct? Because they've asked whether it is elementary or this one. So order, what is molecularity? The number of molecules participating in the reaction. So we know molecularity cannot be 1.5, correct? Okay. That means when the molecularity is not 1.5, this particular reaction, okay, there's no meaning. This reaction occurs in steps. 1.5 molecularity can never be in decimals or fractions, correct? So this reaction occurs in steps. So the reaction which occurs in steps is always called a complex reaction, correct, students? Elementary reactions are those which occur in one step. Complex reactions are those which occur in step by step. So from this particular concept, we have seen the order and we understand that the reaction is complex in nature. Why? Because molecularity can never be decimals. Next, write the units of rate constant for this reaction if the concentration of A and B are expressed in moles. Okay, got it. So here, not this one, sorry, expressed in moles. Now, second part is they say write or mention the rate constant units, right? So they said concentration of A and B are expressed in moles per liter. Simple, students. So here for this concentration A, moles per liter. For this concentration of A, moles per liter. Right? Now when you take out and substitute, you get rate constant unit as this unit, just mole per liter, and you reverse it, it will become half of that. Easy, students. Okay, that means for any question they're going to give you the rate constant. Either calculate the rate constant or calculate the half-life period or calculate whether it is elementary reaction or complex reaction. Next question, let us see one more. So here they have given me the following results have been obtained during the kinetic studies of the reaction. This is one reaction which is given and these are the values which they have got. Determine the rate expression for the reaction. So initially, students, experiment was performed. Experiment number 1, 2, 3, 4. The experimental results, initial values were all this, right? and the final initial values of P was so much, initial values of Q was so much, because two reactants are there. And finally, rate of formation also is given here. So I have to determine the rate law expression. First, as soon as this is given, try to write the differential rate equation always, so that you'll have an idea what is the order of the reaction. So X in terms of P and Y in terms of Q. Now, let us take first step by step. First one. This is, let us take this as rate 1, rate 2, rate 3 and rate 4. Right? So, for the first one, how much is the rate of formation? This value. What is the concentration of P? So much. Initial concentration of Q? So much. Substitute the value, students. Rate 1. How much was that? It is equal to 3 into 10 raised to minus 4, which is equal to concentration of both the reactants. Correct? No? This is for first part. Second rate, students. Let us take the second rate. 0.3 and 0.3, and formation is 9 into 10 raised to minus 4. Note that here you have written this 0.3 of X, 30 of X, and 0.330 of Y. This is also done. Let us take rate 3 now. K into 0.1 into X and 0.30 into Y. Right, students? So I have noted all rate. We have rate this one also. So all the parts are over and we need to find out. Determine the rate expression, rate law for this. So the substitution, I'm substituting there because I have to find rate 1 by rate 3. Okay, right? Questions. So this is your Y value, or 1 is equal to 1 by 3 Y. Second, rate 2 by rate 3. How much is it? Equal to 3x. So now students, see here. I'm seeing the values. 1 by 3. 3 ones are 3 threes are 9. Okay. Now rate 2 by 3. If it comes 3x, x is equal to 1. So rate is equal to k into 2. That's all. Simple as that. Right. So students, these are all your 10 years board papers. 10 years board papers, 10 years PYQs of chemical kinetics. So please watch all the videos. It will be very useful for your board examinations, because a lot of numericals are solved from the NCERT textbook. So all the topics are covered in this. So thank you so much for watching, students. The video starts from 2010 till 2020. So 10 years papers are covered. Try to watch and practice it. All the best for your exam, students. Thank you so much.